syllabus. Okay. So English petrology now it seems a lot. In here it is not. Okay. So this is just one. So for example, from this there is only one question can be framed. The question will be generation, right or not, generation and crystallization of magma. Okay, or maybe just like generation of magma, crystallization of magma. Okay. Basically we will cover in these parts only. Okay. So crystallization, magnetic differentiation, assimilation, etc. So crystallization part there we will cover, and also in these some part in metamorphic these textures of igneous rocks as well. Okay. So how does crystallization take place? Okay. So it's pretty simple. Similarly here crystallization of anorthite, anorthite, and diopside wollastonite silica systems. Okay. This is never asked. Okay. I think the syllabus is pretty old. No matter what book you will open up, okay, you will never find this discussion anywhere. Okay, even in nature we don't really find it. Okay, so diopside wollastonite silica system. Now there is a 1944 paper in which there is a very complicated ternary. You see these are just two, anorthite, anorthite, diopside, anorthite. They're called binary diagrams. This is a ternary one which is very complicated. So you can leave it. Okay, no need to go through that part. It is never asked, has never been asked. Previous batch also I told you don't go to this. It will come this year. Okay, I have notes for this. You will not find those notes anywhere. Okay, usually it's very difficult to find content on this one. So I can give you notes in the additional material for this part, but I would recommend in the interest of time that you just go through first only. Those are the important ones. Reaction principle you have already covered. Okay, so this reaction principle which is given here is basically your Bowen reaction series or Bowen reaction principle. That's what you have to write. Okay, they may reframe the question here and there. Okay, crystallization of silicate magma from high temperature to low temperature and all those things they may say. Okay, but here whenever you hear the term Bowen reaction or reaction principle, you just have to write about the Bowen reaction series. It's as simple as that. Okay, so here you just need to write about the Bowen reaction series. Okay, or Bowen reaction principle. Do you remember what that principle is? You've already covered this in which subject? In which subject you covered that part?
In general geology, it was also present.
In general geology, but more detailed, it was in mineralogy.
Mineralogy,
yeah. So
continuous and discontinuous series, right?
Yes, exactly that one. Okay, so Bowen reaction series, that is called a Bowen reaction principle. So this reaction principle is that only. Okay, so only one question can be framed from this one also. Okay, maybe they can just rephrase it. They may ask you like instead of just like 3 words, they may give you one line, but you have to write Bowen reaction series only in that. Okay, so just memorize that continuous discontinuous series. That basically you get olivine, pyroxene, amphibole. Okay, so like that biotite. So that entire series discontinuous and then continuous series is calcium rich plagioclase to sodium rich plagioclase. So this Bowen reaction series you memorize. So this is a very simple concept. So we will not cover it in English again because it's the same as we covered in mineralogy. Mineralogy, basically it is not in mineralogy syllabus, but I covered it over there so that you are basically familiar with what different kinds of rocks we have. Okay, after that, so this is pretty simple. Petrogenetic. So this is the part, okay, which is I think only a little bit challenging. This is also easy. Okay, so just very few processes are there. Okay, this one textures of igneous rocks. Okay, so this one also we will discuss briefly. Okay, actually basically for this one I have a very nice pre-recorded lecture. I will upload that. You just go through that part. Okay, so there is just one lecture only on that part, igneous textures and structures of igneous rocks. Okay, so you just have to see one diagram, description of the texture, and then what you have to write on that. So usually one question is asked from this part. This part, crystallization of this phase rule over here that you see here, this is called the phase rule. This is almost always asked. Okay, it is like with 100% surety. One of these questions is going to come in exam. Albite anorthite or diopside anorthite. Okay, so this is going to come in exam, so you have to be prepared for that. Okay, so this is what we have. So this is something that you have to be prepared about. Okay, the last one, Deccan volcanic province. Okay, so you would basically already know Deccan basalts. You would have heard about Deccan plateau. I think most of you are aware of that part, right? Deccan volcanic, yes. So that is only there. Okay, so just basically there are also few details about those you have to learn. This is also part of stratigraphy also. So there is overlap, so not a very big deal. For these, direct question will come from 1 to 9. Basically, you have to write like answer on each of those. Okay, so question will be directly write a note on petrography and petrogenesis of granite, write a note on petrography and petrogenesis of cyanite, write a note on petrography and petrogenesis of diorite. Okay, so this is the only challenging part, but again here only 9 questions can be framed. There is not a 10th question which can be framed from this part. Okay, so from this petrography and petrogenesis, so there are 9 questions only which can be framed. So overall in igneous petrology, okay, I will tell you for point number one question. Okay, then 2 questions from here, third question, fourth question, can sometimes in this fourth part sub questions can be asked a little bit of. Okay, so let's just discuss differentiation and assimilation. 5 questions, let's make it. This textures multiple questions can be actually framed. Okay, so if you leave that part 5 and then here 9. Okay, 14, 15. So if you leave this part only 15 questions if you prepare from igneous petrology, your job is done. Okay, so you'll get like 100% marks in igneous petrology. Petrogenetic significance of texture and structures of igneous rocks. Now in this also there is just one slide back only, but here because this is they have not specified which texture. Okay, so whenever they do not specify, it becomes a little bit tricky. So here direct question will not come. Write a note on petrogenetic significance of texture. They will give you the name of the texture which is not mentioned here. So the problem with that is now that becomes sort of like limitless. Okay, so there can be hundreds of textures, but UPSC does not ask you. There are very few ones which you have to remember, which are very important. Okay, I will give you those names also. For example, if you're going through slides, if you have to like focus on few textures only, I will upload a pre-recorded lecture as well. So overall, as I'm saying, basically 15 questions plus the textures part. That is what you have to prepare in igneous petrology. If you can do that part, it's like guaranteed that you'll be able to solve most of the questions in igneous petrology. Okay, so we can basically get started with this part. Okay, so now the introduction is done. Okay, so here I was showing you the syllabus. Okay, so igneous petrology. First of all, what do you mean by igneous rocks? Okay, igneous petrology, study of igneous rocks. Okay, so what is an igneous rock? Okay, so what is an igneous rock? I think most of you would already be aware of this. What is an igneous rock?
Formed by cooling and solidification of the
Magma.
Basically crystallization of magma. Okay, so it forms by crystallization of magma, molten rocks. Okay, molten rocks. Okay, so molten rocks, you can call them basically lava or magma. What is the difference between lava and magma? What is the difference between lava and magma?
Lava is when it comes out onto the surface.
Yes.
Magma is when it is inside.
Inside the earth only. Okay. So you have basically lava is like some when it is erupts on the surface. Okay. So erupts on the surface. Okay. So magma is within the earth. Okay, so even before we jump onto that, there are a few like basic terminology that you should know about. Okay, so another thing is that you should know about is this terms plutonic. Okay, so have you heard about these terms plutonic and volcanic?
Yes, sir.
What is the difference between plutonic and volcanic?
Plutonic inside the earth and volcanic on the surface.
Okay, inside it, plutonic is a rock which crystallizes inside the earth only. If magma crystallizes inside the earth only, it does not come to the surface. Okay, so from magma you'll basically get plutonic rocks. Okay, crystallizes inside the earth. Okay, so these volcanic rocks, they crystallize on the surface. Okay, so these will crystallize on the surface. So that is the difference between plutonic and volcanic rocks. Okay, another important concept here is grain size. Grain size. Okay, so you can have basically what we call fine grained rocks. So we study this in English lectures. Okay, and forgive me if my voice is not very clear today. Okay, I was a little sick for the last few days, so it's still a little hoarse. So fine grained, okay, versus coarse grained. Or extreme category of fine grained is if it is non-crystalline. Okay, non-crystalline. What is another term for non-crystalline in mineralogy that we studied? So the minerals are not even there.
Amorphous.
Yes, amorphous. Okay, so example of this non-crystalline igneous rock is called volcanic glass. What is the technical name for volcanic glass? Does anyone know?
Obsidian.
Yes. Okay, so basically what happens is this grain size that you see. Okay, this grain size is basically dependent on rate of cooling. Okay, so fine grain means fast cooling. Coarse grain means slow cooling. Okay, and slow means it's actually really, really slow. It can take sometimes thousands or lakhs of years also. Okay, that's how sometimes those crystals become so coarse grained. And amorphous means very fast cooling. How do you get basically this glass which is there on the windows? Okay, so it is made up of silicon only. You take some sand, you melt it, and then you cool it down. Now we say in normal terms we are cooling it slowly, but in terms of basically geology, it is a very rapid cooling. Okay, so we don't wait for thousands of years for it to cool. So it is actually very, very rapid. So that is why the window glass that we have is amorphous. We don't want it to be crystalline. If it was crystalline, then basically it will not be first of all isotropic. It may not be as transparent. The light which is coming, it will bend and maybe double refraction will occur. So it will not be very nice. Actually, it happens sometimes like if you see very old glass, it starts to turn a little bit whitish instead of being transparent. That is why, because with time, okay, so some crystals are starting to form. Okay, it is not very stable in amorphous form. Okay, so but overall fast cooling, the faster the cooling, the smaller is the crystal size. Why? Because we'll study the technical reason when we study English lectures. But the thing is, the crystals need time to grow. Okay, so if the cooling is very rapid, there is not enough time for crystals to grow, so they become small. They remain small. Okay, so to get big crystals, large crystals, you need very, very slow cooling. Okay, other thing is like you need presence of fluids. You should be able to transfer ions because crystallization is taking place. That is separate. But this is the main thing. Okay, grain sizes. The faster the cooling, the finer is the grain size. So the fastest cooling takes place when you get volcanic glass. Okay, so you will never see basically plutonic volcanic glass. Volcanic glass will only form when lava erupts to the surface. For example, it may meet water suddenly in some places. Okay, or sometimes the lava is very cold already and it cools down very, very quickly. So in those cases, is what you're going to get is obsidian or volcanic glass. All right. So now, yeah, any questions?
Sir, can this be related to one rule that we have? Like I don't remember the name, but like the bigger is more stable. That was rule in mineralogy, right?
Yeah, that's called Oswald brightening.
Yeah.
Exactly.
Sir,
Yes,
can it be?
yes, it's related to this one. So why, for example, glass also starts to get crystalline a little bit. Okay, because anything smaller crystals they form, but they're not stable because they have large surface area to volume ratio, and large surface area to volume ratio is basically always going to have more energy. Okay, so everything wants to go to less energy state. But again, it's not that in these things can happen very rapidly. So they do happen, but very, very slowly. But yes, you're correct. It is exactly that Oswald brightening. But that is after formation. Oswald brightening happens after formation. So if a rock is there with very fine grains, so slowly those grains may start to grow big. But again, that takes sometimes very, very long time, sometimes even older than age of Earth. Okay, but sometimes if conditions are right, it can be observed. Okay, so
Okay,
now these some technical terms you see for these, okay, grain size and all, but I'm telling you because these things are important. Okay, so fine grained rocks, okay, so or coarse grained rocks first of all we see. Okay, so these are also called pheneritic. These are also called aphanetic. Okay, and okay, and these are also called hyaline. Okay, so glassy rocks. So pheneritic, aphanetic, and hyaline. Okay, so these are the types of rocks based on grain size that we have. Now we have studied from the start. Okay, so that classification from ultramafic to felsic rocks. Okay, so please remind me what are those categories. So at the start we have basically we usually start with basic rocks in here on one spectrum on one end, and then we keep going on this side. So what do we have? So basically even before we have basic, so we have what is called ultra basic. Okay, or ultramafic. Let's write it ultramafic. I will just write mafic. Then mafic. Then what do we have after mafic?
Intermediate.
We have intermediate. Very good. Okay, so here we have intermediate, and on this side we have felsic. Okay. So whenever you see this table, you will always have this division in between. Okay. So always these names are given. There will be pheneritic rocks here. Okay. And aphanetic rocks here. Pheneritic means coarse grained. Aphanetic means fine grained. Okay. So I'm just writing PH aphanetic. Okay. So these are basically coarse. Now these ones that you see here, and these are fine. So please remind me what are the names of each of these. So pheneritic felsic rock is. What is pheneritic felsic rock?
Granite.
Yes, very good. So it is granite. Okay, so in geology, granite is a very specific term. Based on composition, the rock is defined. When you go for example, putting stone in kitchen, house, okay, for construction purposes. So there they call any hard rock, they will call granite. But it is not usually the case. For example, many times you'll see in kitchen black granite is there. Granite is never black in color. Okay, it may have some black spots here and there, but granite by definition is light colored only. Okay, so in general terms, what you call granite is not really granite. Geologically, it is based on composition, and these felsic rocks are usually light colored. Mafic rocks are usually dark colored. Okay, so these are light, and these are usually dark colored. Okay, so granite is light colored by definition. Okay, so what is the intermediate phenolitic rock? What is intermediate phenolitic rock? Diorite. Okay, what is mafic phenolitic rock?
Gabbro.
Gabbro, very good. And ultramafic?
Peridot.
Peridotite. Okay, so peridotite is there. Now, the fine grained equivalents of these. See, compositionally, they are same. When I say phenolitic, means composition will be felsic, but if it is fine grained, what will be the name?
Rhyolite.
Rhyolite, very good. Okay, so this rock that you see in here, okay, this is going to be called rhyolite basically. Okay, and what about intermediate? That one is easy actually. Should be able to answer that.
Andesite.
Yeah, it's based on Andes mountains. Okay, and Andes mountains, as you see, they have like volcanic activity, so a lot of it actually erupts on the surface, and you'll see these andesitic rocks. So it comes after Andes mountains. And what about mafic rocks?
Basalt.
It will be basalt. Ultramafic, sometimes comatite will be written, but sometimes it will be left blank. Okay, so because ultramafic rocks are in mantle, usually they do not erupt to the surface. In early earth, in very old rocks that you see, so you can find those deposits. In modern day environments, we don't usually find these basically ultramafic lavas. Okay, that's because if you have ultramafic rock, you'll basically understand it once you study that phase behavior, binary ternary phase behavior that I was talking about. So you will study over there that ultramafic magma, it is not easy to generate. Okay, so you cannot just like generate ultramafic lava. Okay, so to actually generate ultramafic lava, you will have, or magma, you will have to melt entire mantle, and mantle has the maximum volume of all earth layers. Okay, so this aphanetic rock here will be rhyolite. Okay, intermediate is andesite. Okay, mafic is basalt. Okay, and ultramafic is, you can leave it, or sometimes comatite is written.
So can you just repeat the point about the comatite?
So comatite is just like an ultramafic rock which erupts to the surface, but comatites are usually found, basically these are older rocks. You don't usually find them today, they are not easy to generate. You'll not understand the point now, but the thing is, whenever you have melt a rock, okay, so for example, if you're melting ultramafic rock, it's not that you'll get ultramafic melt. Okay, so melt will be of different composition. Okay, so that melt is usually more felsic. So if you melt, for example, ultramafic rock, you'll get a mafic rock. If you melt, and not if you melt it completely, then you'll get ultramafic only. But if you partially melt it, let's say 1%, 2%, 5%, 10%, then it will have more felsic composition. Similarly, if you partially melt mafic rock, you will get a more intermediate rock. If you melt intermediate rock partially, you'll get felsic, basically melt. Okay, so you'll study this when you study phase rule, you'll understand that point. Okay, but anyway, sometimes that part is left behind as well. Okay, so usually sometimes here this is left just as blank. Okay, so these are some like the basic concepts, some basic things that you should know about, basically terms that you should know, maybe even though you may not get a question on this, but very important that you should know this part. Okay, any questions from this part? Okay, all right. So if there are no questions,